screen recording is working as well. So stuff. Okay, so during the last exercises we have been working on our string X class by adding split and merge and so on, and if I recall correctly we were not quite done doing so. Right, so we have this split function which might be working. Let's quickly review this. Okay, so the split seems to be finished. Let's quickly run it. Yeah, so what we need now is the join function. So for simplicity, the test case for this would be just we take our crumbs, take string v, no, that's say string a, path 3 is equals string a, join crumbs, comma, and we'll just use a / instead, and then we will want, of course, to print it out. Let's grab a print line, or rather Unix path 3 with the / So we need a volunteer to implement that functionality. So the idea here is to just create a new string, go through the list of strings provided in the array and add them one by one, and add always a separator. And there is a small complication that we don't want the separator to be on the beginning or end. So we need the loop to be a slightly more smarter, and only add a separator if there is already something in the string. So who would like to volunteer to implement that functionality? Okay, so since no one volunteers, maybe Miss Chiara would like to implement it. Wait, the network is not connected. You might need to try again because the network was disconnected on the VM. I did notice that before. No, it should have the same address, just that it was blocked here on the virtual machine level. The address works, yeah. So the function is a static function, meaning it cannot access anything on this. It will create a new string, just a new instance of cstring x, and then it will, in a loop, process all the strings fed to it in the array, and append them to this new string it created, and at the end it will return this newly created string. There is a small complication, meaning that whenever it attaches two strings end to end, it should add the separator to a string in between, so that the separator gets inserted where between every string in the array. And this makes the loop slightly more complicated than a very trivial loop, because like the trivial loop would just always append the separator and always append the current entry from the array, but this would end in the separator being either prepended or appended to the resulting string. But we want it to be only present when two strings join, not on the end. So the loop will need some condition internally to not do one of the appendants of separator. There is in principle a less elegant second option, which is always add the separator at the end, and then after the loop just remove the last separator again. But that's less elegant, so it would be better to in the loop intelligently decide whether it needs to be added or not. We don't know the size before going through the whole array, because the entries in the array might have different lengths. If you want to set the size, you would have to add a second loop that would then do that. I think we just create an empty string and then append to it and leave the growing of the string to the append function. First the type, then the variable name, not the other way around. You don't need to add any arguments to the constructor. You can just put a semicolon on it, yeah. You will iterate through the array. And how to do this, you can check in the main CPP, because there we already iterated through the array to print it out in line 76. And this line next to it is also might be interesting, because it shows you how to access an entry in the array. That is quite wrong in multiple ways. So first of all, you append to the result variable, not to the type cstring_x. Secondly, when appending, you don't need to specify the length or anything. You just have to give it the string, which you can. And lastly, the array is called array and not grumps inside this function. The variable is result. You created it in line 307, and to it you can append, yeah, things. Yes, and the thing needs to be in the body of the for loop. Currently there is only the std out inside the body, and we don't want the current body. We just copied it so that we have an example how to access an entry of the array. Maybe first things first. Yeah, or like, yeah, okay, yeah, let's start. Now I would recommend to replace crumps with array so that we have consistent names. It was written with a capital letter. Well, you don't want to add the whole array, you just want to add one of the strings inside the array. We have not, that would work on a more advanced array, but we have not added the square bracket operator to ours. You need to use the add function, like in line 310. So array.add round brackets I closing round brackets. Mm-hmm. Yeah, there are semicolons missing too. And in line 310 we don't really need most of it. We just need the opening bracket and that's it. Yeah, the whole thing. Just leave the opening bracket. Well, in line 310 you should also remove the whole print. We don't want to print to the console while we are assembling the string. Everything except the opening bracket can be removed. Yeah. Well, you also still need to return result. and then run the function to see if it works correctly. You can well, that didn't. We might have a may I have the mouse for a second? We might have a minor problem, which is that if our m is not initialized in the thing, then the insert doesn't work, so we need to fix this. If not m, then does this resets everything? It does, yeah. Then actually just we need only let's just leave it there and attach. Okay, let's try again. Create. Well, we at least know how long this is, so length. Okay, so yeah, that worked. It created path 3 as it should, with no excess dashes. Good, so we have this and it's working. So next thing, a string would be it would be useful for a string to have. Quickly here improve the formatting a little bit so that it's more consistent. Would be a function similar to the split, but in a way a bit more simple. So often when parsing you want to split at a given separator, but you don't want to split at subsequent separators. Our existing split function, however, works such that it will create a full array, which might not always be exactly what we want. So splitting the whole string and then joining everything back after the first entry would obviously be wasteful. So what we want to implement will be a convenience function called split2, which either from the beginning or from the end of the string, depending on additional parameter, will split exactly once and give you only two strings, one that was before the separator and one that comes after the separator, even if it might contain additional separators. And as said, it does this from the depending on the configuration, either from the beginning or from the end of the string. So that, for example, if we have a file name, we could say split at the backslash from the beginning, then we get the triflet, or split at the backslash from the end, then we just get the file name without the path. It can also be used to retrieve, for example, a file extension and things like that, so it's quite useful. To do this, we will create a helper type. Struct, let's call it as string pair, capital P, C string X, first and second. Okay, and here we have our split2 function, which again takes a separator, obviously, but in addition to that it takes a second parameter which if you want to split from the end of the string, not from the beginning of the string, you have to set to true. And the way this function should be implemented is ideally also using find, so it should not be too complicated to do. and we'll need another volunteer for the new function. So who would like to implement it? No volunteers? Okay, then okay, that is not great. During the next lecture you should really join with your computer, and that would be greatly helpful. Okay, then let's say maybe Mr. Thaler. Yeah, I can make a few examples maybe. So we start again with here, let's create a new path. DOS path plugin dev plugin demo // next. Okay, and if we now auto to / command true, then this results in path name punct first is equals to this, and path name is equals this. And if we do it differently, name next. If we take path name second, not just path name second split at comma. No, let's do it with the other one. Let's go with DOS path. Just split this at here without the true. Then this one will be this, and second will be that. And now we add a third demo case. Auto, and this is then drive path, and this is then name next. I kind of try to encode in the name of the variable the meaning of the first and the second argument. So we take the path name, take the second, split 2, add the dot without L, add the dot, comma, again from the back, and here we expect then a split like this. So this is what it should do, and in principle it is quite easy. You create a string pair type as a return type, then you use find. Do we have a reverse find? We do not have a reverse find. That is not quite ideal. Reverse find would be very helpful, but since reverse find was scheduled as a homework 2 weeks ago, then if you have already submitted that homework, you could just provide your solution for rfind and then use it in the split2 function. to split the string from both ends, because this is like the most convenient way. Just looking from the back. Yes, sure. Run the test case. Yeah, let me fix that really quickly. So first of all, here we just a new line for good measure, and here just make just return an empty an empty result so that it doesn't complain. Run. Find test 14. Well, is that correct? 0 and 16. What was the test string? Let's see. Find long string. So test is in long string at the end, and then find capital test. Okay, so there is a difference in what it should do. So the rfind should still return the offset counted from the beginning of the string, not reverted and counting from the end of the string. Well, no, because it still starts searching at the end. So it will find the last occurrence of the thing it's looking for. If you edit an offset, then it will find the second to last and so on. It processes from the other end. As far as I see, the finding works well, just the return value calculation should be different. I think you just need to remove main and minus, and then you will already get the either the right result or close to the right result. We will check that then. Actually, just I think it's really just line 219, where you just need to return I instead of the whole thing. And you can keep the current code, just comment it out, because this is also an interesting approach on the rfind function, so it's not wrong per se, it's just the behavior is not what one would usually expect. And for our use case, it will be easier to have it work this way. Yeah. Okay, let's run it. So test is 0, the other one is 16. Let's see. Main test string 0 is correct. 0, 0, 1, 2, 3, 4, 5, 6, 16. Yeah, that should be working perfectly now. So now you can use find and your rfind in the split2 function to create the splitted strings. What do you mean? You have a whole string of a given length, and then you create two strings which are both shorter than the original string. Mm, mm, mm. That might need some fixing. Well, Well, there's two observations. First of all, you don't need a loop in this sort of a function. And second is our return type is supposed to be a strip pair and not an array. S strip pair, as in line 349. S not C, it's S strip pair, it's a struct, not a class. And the result doesn't have an append function, it only has a first and second member, which can be assigned with a direct assignment. You don't need a loop at all, because you only are looking for one separator, one instance of the separator. You are using find and or rfind, and that's it. You don't need to loop and then find another one, because as soon as you have found one, you already have what you wanted. Found size substring position. Well, you cannot use append on result. You need to use the first or second member variable and then just assign to it. And the second thing is you need to assign the second variable. So when you use find or rfind to get a position, if you got a position, then you are adding everything before the position to first and everything after the position to second. You can that you already have the found variable in line 361, and you can use it for both purposes. You just use once you use find, and the other times you use find plus 1, which is you don't need to cache it in as a separate variable, basically. Okay, so first things first, remove the loop in line 360, because we don't need a loop. Okay, now we have our find variable. You are checking whether find is -1, so if we didn't find anything, then you can just set result dot first. The else, you will need the else. In line 364, just write result dot first is equals capital letter, like written in line 345, just one capital letter. And this is just equals asterisk this, because we haven't found anything, so we just return the entire string as is. Equal to asterisk this. not struct, just asterisk, just a asterisk symbol and then this. And you don't need break because you are not in a loop. Okay, and now the second part in the else. So if we have found something, then what we want to do is we want to set the result dot first to everything from 0 until found, and result second found plus 1 till the end of the string. So you can use substring here, for example. Yeah. Well, you want to get the string, so you need to use the substring function to get a piece of the string. Mm-hmm. Well, line 369 needs some improvements, but you can first complete the second line and maybe then it will become apparent what needs to change in the line above. Well, pos is just 0. We have not assigned it anything, so we don't need the pos variable. You can just get rid of it. But it's 0 everywhere, so you can get rid of it everywhere. Yeah, remove it from line 357, and here just comma 0. Because you start at the start. Actually, no comma, just yeah. And remove where you have the mouse cursor in line 357. Yes. Okay. And you also don't need len stir and len sept. This is also not necessary, as far as I see. Yeah. You need to think about what arguments to pass to substring in the first and the second case, because this needs some improvement. Not the whole string, starting at the beginning of the string until the position where you found the separator. It will be 0 and found, no minus. And in the next line, I think it needs to be found plus 1. Okay. And what we also need to take care of is the from the end parameter. So currently the code only looks from the beginning. It does not look from the end. It should use either find or rfind depending on if b from end is true or not. you need to check the parameter p from end, which is defined in our function prototype, and depending on whether it is set, use either find or rfind. You can use an if or the trinary operator, whatever you prefer, to somewhere around line 358 make a decision whether you should use find or rfind, depending on the value of b from end, which is the second argument to our split2 function. Not quite like this. You just check if rfind is true, and if it's you just check if b from end is true, and if it is true, you are using rfind, else you are using normal find. And you don't return anything. Basically just instantiate size found before your if without any assigned value, and then assign value to found as the result of find or rfind inside the if and its else block, depending on the variable value. No, the if was correct. Now copy the first half of the line in line 361 to 357. Before the if. And semicolon. Now from line 362, remove size t and put a else before it. And a space or a new line. And now in line 360, you just write find is equals rfind, found is equals rfind separator. 1 equals. You want to assign. We are not comparing anything. Well, rfind from separator. You need to call the rfind function. You don't want to just receive its address. Yeah, and separator in the middle. No, just a separator. You are looking for the same thing. as before, just from the other end of the string. You have the separator variable, the argument which is passed, and then you want to just pass it along to rfind. Just as you did in line 363 with find. Yeah. And a semicolon. And I think there is a typo because it should have made it yellowish if it would be typo free. And R is missing. Yeah. Okay, then you can go to main. Scroll down. Down, down, down. And here add a few lines to print the content of path name, drive path, and name x, so that we see what we've done. DOS path. Well, for DOS path it's correct, but you also want to print path name, drive path, and drive x, and there you will need to refer to the internal first and second variables explicitly. Yeah, but path name is a struct. It doesn't have a C string function. You need to refer to the first and the second. Okay. Well, should be dot first and then C string? And then you should print some other some separator and then print the second as well, so that we can see both values what they are. well, C string in line 96 needs a a bracket, open close. And for the other two lines, do the exact same. Well, first of all, also add a separator between the two strings, otherwise they will be printed together. Like just shift out some space dash space or something like that. No, you need something that will be printed, like another shift operator. And between the two shift operators, write quotation mark space dash space quotation mark. Space dash space. A dash, yeah, like a minus character. And then do the same thing in the two next lines, so that you print both with a separator. No, also first. You always print first, second, with the separator always. First, second, yeah, that could run. Let's run it and see if it works. You wrote result, you need to write return result. So let's see. This is our main string. Then we have path and name. That looks correct. Wait, something's very weird. Okay, so this needs to be always the same variable, of course. It was a small mistake here. Okay, let's see. Name. So C and path, correct file and extension. Yeah. Okay, that works. Nice. So let's see. What else we might need? We have a compare function. Yeah, we have a compare function. Okay. Good. So, and we are not doing much with the compare function. So what would be nice here to add is to increase the functionality of our compare function. We would like it to do two things, which the current one does not do. One is we want length to. So we want to add a length to compare and an offset. So basically that we can. So maybe let's call it a compare x function. That it's extended compare x. It takes the string to compare with, and then it will take an offset. So null, it starts at 0, and the way we would do it is that compare x returns true if the comparison is true. Well, sorry, it returns 0 if the comparison is correct, or 1 and -1, but it will not, like here, bug out if the length, if there is just a length mismatch. So if we are comparing with a longer string and only a portion of it, and this portion matches, then it will still return that it is correct, even if the string then continues and more stuff happens. And the second thing we would want from our compare function would be the ability to ignore the whether it's upper or lower case. So there and no. Okay. So with this function, then if you have uppercase and lowercase, just let it no case or ignore case if we don't want it to long. So if we have like a string which contains some, let's say, uppercase text, and you are only searching for lowercase, or vice versa, it should still be able to successfully do the comparison. Yeah. So let's see. So we have 4 participants. So maybe Mr. Armin would like to implement that. Yeah. Well, doesn't say the same. Well, we need a check for the case sensitivity, so it needs somehow to be able to see that they are the same if only the case is different. And we should also have a check whether the remaining length in the string after the offset, if this is less than the length of the string we are comparing to, because if it's less, then it cannot match, because the string will be over before the entire match string has been matched. If this string's length, first of all, if it's less than first of all, if it's less than offset, then then it's false, as then it's well, -1 or something. And then if length minus offset is less than the length of the other's length. So there are both cases where it cannot work if offset is wrong. And then, of course, if whatever's left is shorter than what could be. Well, if m length is less than offset, okay, but the first condition needs to be removed. I would just remove the first condition and then add a new second condition. That would be the simplest fix. Yeah, and then or length minus offset. Well, mu length minus offset. Yeah. Um, the simplest way would be to always convert the character from the current string and the other string to either lower or uppercase, and then always compare those with each other. And the comparison, the conversion is not that difficult. Um, uh, do we have it already? Did we add it to lower? Well, yeah, but we want to do it ourselves. It's not that difficult. Well, we just need to review the ASCII table. Well, one of them. We will see. Capital letters start at 65, correct. So basically you are just checking if it's within the range 65 to 90, then you add to it so that it will fall into the lowercase range. And you only need to do it like here for the character from each string. And then compare those instead of the ones which are compared currently in the code. I think so, yes. They start at 97. It should work. You just need to return it. Well, you don't call to lower on pdata, that's still an array. You need to put... But that's not how C++ syntax works. You need to take the thing and paste it into the function. Yeah. I mean, let me take the mouse. I'm in this. Also, it would be advisable to cache the two characters, since we are doing two comparisons. It is wasteful to convert them, each of them twice. So make like a variable lchar and rchar, and then assign to them their respective lowercase values, and then do the two comparisons on them. looks correct. But you of course need to check if the argument is set or not, so it should be conditional. The most elegant option would be a trinary operator in the line 185 and 186. It's a condition, question mark, return value if there is condition, or return value if it's not set, and the same for the next line. Okay, so now we just need a quick test case, and it's done. I guess there should be, but maybe there isn't. It seems not to be. Not C string, it's an integer already. It can be printed as is. Okay, that should work. It said -1, so y compare to. That's not correct. Compare 2 should be the one on which you are comparing. Compare 1 should be the one what you are comparing for. You didn't. Well, it's still -1. Well, the offset is certainly wrong. Compare is much further down. The comma 4 should be comma something else. Well, yes, but you need to start the comparison there where the match will be, otherwise it will say -1 or 1. Well, not quite. Result 1 also means a mismatch. 0 is when it's the same. So maybe it's 18. Okay, now I count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It is 18. Let's put a breakpoint and see if it's really 18. So this one is 19 is C, and this one is also C. So let's see. Oh, this is wrong. It will keep comparing past the length of other length. This needs to be only until well, length of other length. Yeah. Yes. Perfect. So with this we can already do a few nice things, which will be a homework. 2011 2025. Yeah. Okay. Um, so these two functions starts with checks if the starts with the following prefix if the current string ends with the following suffix. So these are quite convenient functions to have. We can pass to them also the ignore case thingy, and since it was so much fun, we can add an optional assignment. Ignore case to split and split 2. Yeah, this is, I think, quite a convenient thing to have, case insensitivity. So that will be the homework assignment of today. I think our string is already quite powerful, so we won't need to add much more functionality. So in the next exercise we will be playing around with our C array, and we will add a lot of nice thingies. So we will add operator square bracket, and we'll add iterators, and we will want to have some, maybe a find and rfind. It's easier with regard to search. Wait, there is one thing, our string is missing, which we will add, which I will add during the next lecture. But maybe I should write this somewhere else so that it's not confused with the homework. Here, to do add comparison. Actually, we can do it right now. Poll operator equals other. There should be return compare from author is equals 0. So if we have this comparison operator, then we can do much more nice things here. So we can make a find and rfind function on the array, which will just use the comparison operator of whatever type is held by the array to compare the entries. So if we make an array of ints or array of strings or array of whatever, we will be able to search for it just using the find operator. Then we would of course want a mid, which just is like just for an array. And then we will see what else we will want to add. And furthermore, what we'll also add at some point will be a list, so a linked list. It cannot have as many nice things since it doesn't have access by index. And then we will maybe also create a more complex structure like a hash table, which is quite useful to have. But since we are out of time, I think this is a good point to stop for today. I will upload the recording and the new source code to Moodle, probably in the evening. We will see each other for the lecture if you are participating, and if not, then next week. See you. Bye bye.